A candle. It seems something very simple, doesn't it? Well, it is more complex than it seems. Candles go through various industrial processes and have to pass various standards for the product to be of quality. The present project consists of a mechatronic system that monitors candles, focusing on the length of the flame when there is a change in the cross-section. The system consists of a structure where in the central part of the base the candle is located. Similar to an elevator, the cabin that contains the temperature sensor and LM35 will be located at the same level of the flame. While the candle height decreases, the cabin will get down automatically and thus measure a uniform and approximate temperature of the flame. The movement in the cabin is achieved thanks to a geared motor connected to a simple pulley. The circuit is very simple. An external source provides power to the driver motor, which will control the direction of rotation. If the shaft rotates clockwise, then the cabin will go up. If the shaft rotates counterclockwise, then the cabin will go down. The LM35 sensor is connected to its respective pins. The Arduino board works as the controller and data acquisition card. Thanks to computer vision, a very accurate approximation of the length can be determined. In this case, the length of the flame and the dimensions of the candle. This is achieved thanks to the algorithm that uses the AruCode library, which uses this print code box. It gives a reference of measurement. The appropriate color mass range had to be calibrated for a correct color recognition. In this case, fuchsia for the cabin, turquoise for the candle, and whitish yellow for the flame. To improve the measurements, it was necessary to set up a suitable scene. Black cardboards were pasted on the wall to give a dark background, and the wood was painted black too. As a webcam, I use my cell phone with the application Irium Webcam, which allows to send the video to the computer via Wi-Fi. The cell phone was placed on a special base, designed for it doesn't move and keep the stability. The control was carried out for the Pi serial library, which allows you to send characters from the Python program to the Arduino board via serial. Therefore, a fusion control was improvised, just sending characters. The screen was divided into 5 sections of the same number of pixels. The Python program will recognize when the flame and the cabin are in different sections. Then the rules are applied. The control will indicate the clockwise or counterclockwise rotation of the motor. In this way, it is known if the cabin must go up or go down to get closer to the flame. All the measured data were stored in CSV file to be processed and filtered. With the information, the design of experiment is carried out, which determine if the sense parameters influence in the length of the flame. As design of experiments, a field factorial design of 2 factors and 3 levels was chosen. The factors are circular cross-section, which is dependent of the height of the candle and can be obtained with geometric calculations. The second factor is temperature, while the response variable is the length of the flame. The 3 levels are low, medium, and height. 3 replicas were made, so there were 27 run orders. The Pareto chart indicates that 2 factors, cross-sectional area and temperature, are influencing factors. Even the interaction also influencing the length of the flame. The main effects plots determine that the smaller circular cross-section of the candle, the smaller the flame size. However, it has been found that during the measurement of a medium temperature, the flame is more likely to reach its maximum length. In this way, the prototype of the automatic candle monitoring device, a mechatronic product, was successfully tested. The candles with a cross-section with a diameters of 12 and 13 millimeters can provide confidence that they won't exceed 45 millimeters in height, thus respecting to the standard F241709.